two-dimensional arrays are stored as arrays of arrays. And we create them and index them similar to 1D array objects. So consider this matrix of numbers here. So we have 4 rows by 4 columns. And we'll represent this as a two-dimensional array as follows. So we have 2 pairs of brackets, and our identifier will be matrix. And I'm going to use an initializer list to create that matrix. So in the first row, I'm going to have an array of numbers, being 1 to 4. And in the next row, we have 5 to 8. And in the next row, 9 to 12. And finally, 13 to 16 in the final row. So effectively, our initializer list consists of initializer lists that each represent a 1D array. So here we have an array for each row of this matrix. So therefore, when we want to index this array, we index by row, then by column. So in other words, if I want the number 6, it's on the second row. So we start from index 0, 1, and it's in the second column. So if we print this out, we should get the number 6. And if we want the number 8, that's in row 2, column 4. So column 4 is index 3. So we start from 0, 1, 2, 3, and that gives us our number. And one thing to note is row major order, which refers to an ordering of 2D array elements where the traversal occurs across each row. So when we traverse the array, we traverse row 1 followed by row 2 and so on. And we also have column major order, where the traversal occurs down each column. So we traverse column 1 first, being 1, 5, 9 and 13, and then we traverse column 2 and so on. And we'll look at this more closely when we look at traversals.